All right, to integrate x cubed times cosine x dx on the integral from pi over 2 to negative pi over 2, we're going to use the method of, we're going to use the method of, that sounds funny, integration by parts. Okay, so integration by parts is how we're going to do this. And so we're going to let this term equal our u, and the reason is because as we differentiate the u's, the powers on x are going to drop down to eventually we're going to get cosine by itself, which means then that this term here is going to be our dv. Okay, so we'll have to apply the integration by parts a couple of times to reduce this power down. So let's go ahead and do that. So we get u equals x cubed, then du is equal to 3x squared dx. dv is equal to cosine x dx. Okay, so if I integrate cosine, I'm going to get a sine function out of it, and the constant term we're going to ignore. And to quickly check, the derivative of sine is cosine, so the integral of cosine is a positive sign. Okay, so utilizing the notation here, we're going to have that, I shouldn't have wrote that right there, but the integral from negative pi over 2 to pi over 2 of x cubed cosine x dx is equal to uv, so x cubed sine of x evaluated from negative pi over 2 to pi over 2 minus, so that's these two evaluated at the endpoints, minus then the integral left over, which would be the integral from negative pi over 2 of pi over 2 of v du, which is going to be 3x squared sine x dx. Okay, so utilizing the same exact idea as before, we're going to let this equal u, and this term here is going to be equal to our dv term. Okay, and the 3 in the minus sign we'll be factoring out. We can also evaluate this between the limits of integration, but we'll save all of that for the very end when we clean up all of the results. Let's get the integrations knocked out, and then we'll come back and clean up the constants. So I'm going to focus just on this integral right here. I'm going to move the 3 out and pretend that that is not part of the u term. Okay, so I have just the integral from negative pi over 2 to pi over 2 of x squared sine x dx. Okay, so if I let u equal x squared, then dv is equal to sine x dx. Okay, so du is going to equal 2x dx, and v is going to equal negative cosine x. Okay, so this part would equal then x squared times a negative cosine x evaluated from negative pi over 2 to pi over 2, and then minus, and then we have u dv, so it's the integral from negative pi over 2 to pi over 2 of 2x cosine negative x dx. Okay, so the negative and the negative will make that a positive, and just like before, I'm going to ignore the 2. I'm going to move that out, and this will be my u term, and this will be my dv term, or my v term. Okay, all right, and so computing then the remainder of this integral, we have the integral from negative pi over 2 to pi over 2 of, we have x cosine x dx, and this is positive, of course. So u here is going to equal x, so du is equal to dx, dv is equal to cosine x dx, and v v is going to equal sine of xd. No, x dx. Alright, and then this is going to give us x sine of x from negative pi over 2 to pi over 2, and then minus the integral from negative pi over 2 to pi over 2. And now, just with what's finally here, I have sine of x dx, where my u terms have all finally, or my x terms, my u terms are all finally all gone. So now, finally at a point where this is going to give us the integral, and so now we'll go back up. So the integral of sine of x is minus cosine of x, and a minus, it's a minus, so that makes it a plus cosine of x from negative pi over 2 to pi over 2. Now you should notice that cosine of pi over 2 is 0, so this entire term is actually going to give us 0. Likewise here, in evaluating this integral, x sine of x is going to be 1, and sine of negative x, pi over 2, sorry, is going to give us negative 1. So this is going to be pi over 2 sine of pi over 2 minus a negative pi over 2. It's going to be a lot of minuses. Minus a pi over 2 sine of negative pi over 2. Okay. So this is a plus, and then sine's an odd function, so that negative comes out, and so you have pi over 2 sine of pi over 2 minus sine pi over 2 sine of pi over 2, so this actually equals 0. Okay, so you can see here that this term equals 0, which then leads to this term being 0. This is 0 because sine of pi over 2 is 1, sine of negative pi over 2 is a negative 1, and a negative pi over 2 here. So we have a negative and a negative instead of positive, so we're subtracting the same exact term here, which also is the exact same situation up here. Okay. In general, this negative 3 that would be here would multiply this entire value and this entire value, but since each of these terms are 0, the bookkeeping was pretty easy in that regard. The cosine is 0 when you integrate this, as we saw here. So this is the reason why this is 0, because the sine is exactly the same on both sides. It's symmetric, so it's 0. This is an even function, and cosine is 0 at both of these values, so it's always going to be 0. So each of these integrals results in a very fancy way of getting to the point, which is this integral is cosine's an even function, x cubed is an odd function, so an even times an odd makes it an odd function. Odd functions integrated about the origin with symmetric limits is going to give us 0 integrals. That's a nice check. But here's an integration by parts with several steps. Again, just be careful when you have non-zero values. So from this point and this point, when you have to do integration by parts multiple times, just keep those constants in front to make sure that you don't make a mistake in your bookkeeping. Other than that, I hope that was helpful, and that is it for this video.